So it's part 2 of lesson 11. We're building our REST API. So everybody at the end of this class should be able to put these things on their resume. You can put .NET Core, you can put Web API, and you can put REST API and RESTful Web Services, because we're doing all those things. JSON. So 4 technologies. If they're not on your resume now, they all can be after today's class and after you have a chance to work with this on your own for assignment 2B. So we've got our 2 get methods working, our get all and our get single. So we will need to deal with post, put, and delete. So notice the URL never really changes. We're doing them all just at API/albums. We just change the method. So for post, let's also change the return type here. May as well change this to, again, an iAction result, so that we can either return an error or a proper HTTP status along with our newly created object. Okay. So instead of taking in a string, we're going to take in here an object of type album. So the first thing we want to check is whether we actually got a valid album or not. We'll check our model state. The scaffolding controller we did in our MVC web app, it has the same code. We look at the orders controller post method. Well, it's called create, but the very first thing is it checks if it's valid, so we're doing the same. Reverse logic, we're saying if it's not valid, then let's return. We've got a bad request method. So this will send, I believe bad request is HTTP error code 400. So if they haven't given us what we want, we return 400. Otherwise, we add the new album. Save. We don't have to map the fields. And then in this case, we'll return the created at action. So the name of the action, we can just put it in here as post. Oh, sorry, no, I don't want post. We want to call our get and pass along our, sorry, change that to get. So this should return the same album object back, but now it's going to include the ID. So the calling code can then capture that ID of the new album. And this created at returns an HTTP status of 201, which means a new resource has been created. Now we have no way to do this in our browser unless you build a form that posts to this endpoint. This is where our Postman tool is helpful. Ravinder Paul, question?
Yeah, like we are doing it from a Java application and say album object. So is that the same as Web API, the album object, how it will correlate it?
Well, it just gets a JSON object. It's not strongly typed, it's just JSON. So in your Java application, you have to take the JSON that comes back and then map that to an object in Java.
So you don't have to map it?
No. No, because this actually is just JSON that comes in. It's JSON. As long as the JSON object maps to our album definition, it will be fine. We'll see how this works. So in our Postman tool, I'll take out the ID because we want to just post two albums. I'm going to change the method now to post. And then in here, we've got to supply a body. Right? So I will just click on body. And in my tool, it lets me specify what content type. So obviously, I'm going to pick JSON. Right? I'm not sending form data or raw or binary. It's JSON. So we can just set up a simple array. So title, call it afternoon album. I don't need to specify an ID. So if I send this request, it will do a post to that endpoint, and it'll pass in this object. So let's try it. Okay, we got a 500 error with a full HTML response. Aha. Doesn't work because of validation in our SQL Server. We can't save an album with no genre. And I'll give you a hint. If we fill in a genre and run it again, we're going to get the same error with the artist. So we do need to just add those to our body. So if I just add a genre ID of 1, and an artist ID of 1, I should be able to resend. Oh, okay, whoops. We're passing it in here, but we haven't added those fields to the model. Model still doesn't know. So we just need to quickly add genre ID and artist ID to our model class. That's easy. Just add 2 quick integer fields. Jump over here. We better set them as required because we know they're required in the database. Set and set. Just add those 2 properties. And we should be able to try again. Go back to Postman, try one more time. So now we've got a new album with a new ID. We should be able to now run a GET request on iWith 676.
So put that in your database?
Yep.
But you didn't have to put any like credentials or anything in this program.
We haven't done any authentication. It's only in our web application controller that so all of this is public. Now, normally we wouldn't make it public, but yes, for our purposes, if we have a couple minutes today, we can talk about how you would do it. But for our purposes, we're just going to allow it to be public through the API. So there's our post. I didn't get a chance to do put this morning, but I think we should be able to do put Now, so we want the ID as part of the URL, and then obviously instead of a string, again we want an album object, and that's really just JSON that matches our album. Sorry? Update. And again, we'll return an iAction result instead. Void. Now our code's almost the same as with post, right? We're going to check the state, and instead of calling add, we're just going to mark the state as modified and then call save. And then we don't want to use created at because that generates a 201 code for creating a new resource. We're not creating a resource. So we'll maybe have to look at what's an appropriate HTTP status code. So we'll just copy this first section. Exactly the same. If our album model is invalid, throw a bad request error. If they gave us something else, if they gave us a customer object, throw a bad request. So we'll mark the state. It doesn't know what that reference is, so we just reference Entity Framework Core. So this is the exact same code that our scaffolded controller has in our web application. If we look at the edit post method over here, here's edit. If it's valid, mark the state as modified, call save changes. We're just replicating the same code. Call save. Oops. Call save changes, which will perform the update. And then we'll call the get again so the user can see the modified object. Except instead of created at action, I think we want to just return accepted. I think that's HTTP 204, which is data accepted but not creating a new resource. So that's kind of a common one for doing an update. Oh, okay. It doesn't have 3 overloads. So which maybe change accepted at action. There. So that'll return a 202 response, which is accepted. So now we can try and change that album that we built. We could either change the price, we could change the title, maybe we'll change both. So I'm going to change this to put. So actually, I'll just run my get one more time so we can see. So right now my album's called Afternoon Album 12.99. So I'm going to change this to a put. Patch and put, by the way, are both used for update. Some developers, I don't know why there's 2 methods and why they're not called update. These are very old method names that have kind of moved from legacy and they've stuck around.
It is also a post request.
Sorry?
It is also a type of post.
It's a type of post, yes. So I'm going to go into my body here. I'm going to maybe update the album title. Artist ID 1 is AC/DC, so I'll put in a real AC/DC album name. Maybe I'll change the price as well. But I also now need the album ID. So if this runs successfully, it should change both the album name and price. And we'll see it in the response body if it updates successfully. And hopefully we'll get a status of 201. I think that's what we said. Well, we'll try it. Sorry, 202 accepted. Right? So now our album is called Hell's Bells and the price has been updated.
Can you pass also the album ID through the JSON object?
Great question. Let's try it. Best way to find out. I'll take it out. I'll change the price again. It may not be because the ID, I think we do need it. Here's why. Because there's nothing here that binds the ID to the album. So I think this will fail. I'll try it, but it's not going to know what album to update without the ID. So, I mean, we could actually do this without the ID. We don't really need the ID parameter as long as it's in the body. But it's usually more descriptive if we're working with one particular record. It's a good idea that we include that ID as part of the URL, other than doing a put or a delete just on our root URL. So let's try it, but I don't think it's going to return anything. So I suspect our response is going to be yeah. Database expected. So we do need to include the ID in the body.
So it can be like inconsistent, like somebody's calling like some other ID in the URL and then posting something else in the object.
Technically, yes. The URL is really just an endpoint. Right? It's the actual parameters that are passed. That's the actual JSON data, are the method parameters.
Yeah, but my question is like somebody can put some other ID in the URL while doing that put request, like say API album 5, and then when it sends the object, it says like some album ID something.
Yeah, in effect, the ID gets ignored. So if I put in a different, I see what you're saying. If I put in, so there is an album ID 389. I put this, it doesn't update 389, it will update 676. It's based on the JSON object. So the ID, it doesn't even really need to be here. We could remove that entirely from our method. We don't need it. It's just there to be descriptive in a way. So there's our put. And our delete is going to be pretty similar. Again, we'll return an iAction result. So here we're going to need to take this ID, look up that album. If it doesn't exist, return a not found. If it does, we just use Entity Framework to remove. And we could just return an OK response in that case. So, we'll try and find the album. return a 404 if we don't have it. Otherwise, we will remove it. We don't need to return any data because we're wiping it out. So we can just return an OK status. Let's change this to say albums. Well, I should be able to delete that now by changing my HTTP method to delete. So now if I delete 6, and the way we can check is now to do a GET request. It's gave me a 200 OK. Now I can flip back and run a GET. And now I get 404 because it's been removed. So there's all of our API methods. Even though we wrote the code ourselves, that's okay. It's probably a little more informative to write it ourselves rather than just to scaffold it. Now we could try and scaffold. Now that we have it set up again, I'm going to try one more time to scaffold the controller now that we've set it all up properly. You guys have helped me debug my issues. So what we'll do in our web application, we didn't have an albums controller. We called it the store manager controller. So we could create store manager controller still based on the album model. So I'll make a new controller. We'll see if it will actually work now. So I'll add a controller with actions using Entity Framework. So our model class is album. Our DB context is music store. I'll call it store manager. We'll see if I can actually scaffold it now. So now I can scaffold it. It's fairly similar. It calls our database class underscore context instead, and it injects it in the constructor, much like we've done. So we get an IEnumerable of albums. Now they've actually used, we won't get into it too much. You guys will do a lot with this next semester. The other methods are actually written asynchronously. So asynchronous code is something that originally was created on the server with Node.js, but now we can write asynchronous code in C#. In a nutshell, asynchronous code means when we start calling one section of code or one method, we can do other things while this line of code executes or this method executes. In case it's a long running process, it doesn't prevent us from doing other things. We can start here, go do a bunch of other things, and then return over here when it's done. All the code you're going to write next semester in advanced web programming with Albert, that'll all be asynchronous. So when we scaffold the controllers here, it actually says that this method is asynchronous. So there's two keywords here that tell you this code will run asynchronously. So we wrote our code with synchronous code. We could have done it asynchronously. So we have this async keyword here in the method definitions. The other thing is all the calls to the database use this await keyword. If I take await out, it'll throw an error. Right? Because now the return type is wrong. If it's an asynchronous method, we need to call that method asynchronously on the database. So it complains when I take out the await. You can see the error. The async method lacks await operators, so it will run synchronously. So it will still build, but it's no longer asynchronous without await. In Node, in JavaScript, we have this other really complicated syntax. can actually show you quickly because you'll be doing it. Oh, here. Good old lesson 1. So here's 2 versions in JavaScript. So here's the synchronous version. So this looks pretty normal, right? Open a file, print some contents, open another file, print some contents. So this code happens one thing at a time. If there's a million lines in this file, nothing else happens until those million lines are read and the file's closed. Then it writes out the contents, writes out a heading, opens the next file. So that's our synchronous code. Our asynchronous code, so in C#, we use async and await, which is a little cleaner. In JavaScript, you use this funky syntax called the callback. So we have another function, we have a function as a parameter of another function. So that allows us to read the file, and while that file's reading, we can carry on. Do this, etc. So one method or one line of code doesn't block subsequent lines of code. So you'll be doing this all semester next semester. This syntax is a lot messier. In C#, this is newer. Asynchronous code is a lot newer in .NET. It's been around in JavaScript for quite a while, for almost 10 years now. So the syntax is a little bit improved in C#. So our main method, our get method, our original get method is synchronous. It's not asynchronous. But all of the other methods here are asynchronous, and you see them all with await when interacting with the database. So it has your 5 methods here that work. It even actually checks that the album doesn't already exist when you're creating. So if you want to scaffold your controller or controllers for part 2, that's fine. If you want to create them yourselves, that's fine too. The way I'll test your part 2 is I'm simply going to use Postman. I'll run your get methods, and then I'll try a post, a put, and a delete. I'll just make a little JSON object that matches your model. So if you have a games model, for example, I'll just make a JSON object that matches the property of your games model. And I'll run it through Postman, see if it works.
So basically you don't have to do anything other than scaffolding?
Pretty much. Well, you have to set the whole project up, right? So you need a new Git repository. We also need to put this online. Because the other thing is, in order for your Java application to consume it, it should be running online on a fully qualified URL, right? So let's put this on, I'm going to push it to Git now and set it up as a new site on Azure.
Before you do that, I don't think that you re-added the await thing.
Thank you, Sean. I did not. I'll publish it with 2 controllers. They both basically do the same thing. My store manager controller is the scaffolded asynchronous version. My albums controller is the manual synchronous one. So we'll build, but basically our API is done. Now we won't implement it. We'll talk briefly. I'm going to put it online. We can chat for a few minutes about authentication and documentation, because those are 2 other important things we have to think about, kind of beyond our scope for today. But we can at least, I can point you in the right direction. So I'm going to upload to Git. We've got our completed API. So I'm going to go and create a new web application on GitHub, on Azure. So create a new web app. I'll put it in my existing resource group. I don't need to have a separate one. And then we'll just connect it up to GitHub, same way we do normally. There is also a gotcha in here I need to show you guys. There's a fix for, not a not a fix, but there's a way around it. It shouldn't affect you accessing this API from elsewhere. Oh, I knew there was something else I wanted to do. Good, we got lots of time. Because we don't have a Java application to consume this today, I've created a PHP file that will allow us to put in the endpoint of an API and go and fetch the data from there. I've put that file on Blackboard. We can download it. I'm going to upload it to my AWS account and then use AWS to fetch data from Azure with my API. Okay, so I'll go into my deployment, connect it up to GitHub. Choose my API repo. One thing I'm going to show you, I'm going to enable, this will take a little while to pull it. If you scroll down in here, there's a section here under API called cores. Now, Scott was having this issue the other day because he was asking me, he's teaching a JavaScript class, and he said, do you have an API? I want to teach my students to use Ajax and JavaScript to call an API and consume the JSON. The problem is we could do it. So I gave him one of my APIs. I said, yeah, it's on Azure. Just use mine, and I'll build one in class this week. You can use it. The problem is this thing called cores. Anybody heard of cores? Anyone know what that acronym stands for? It stands for cross-origin resource sharing. By default, for security, Azure and many other servers they're okay with Java calling the API from another domain. They don't like JavaScript doing it. So they block it by default. It's kind of like that. So if you go into the cores setting here in Azure, it allows JavaScript running in a browser on an external host to hit your back end. So by default, they don't allow this. So Scott said, this is all running great. I can read a JSON file locally, but if I stick my JSON up on Azure, it keeps getting blocked. We found out, here's the fix. So you can either specify the specific domain, or you can just put in star, and now it will allow remote JavaScript to call your API. This shouldn't affect you if you're trying to call it from Java. It should be okay, but just in case, you can put in star here and save. Think this only affects JavaScript. Okay, let's check our deployment, see if it's done yet. That's annoying. I may be running out of space. I am running out of space on Azure. So this may be part of the problem. I may have to delete something.
Do you get the window that holds your, I guess your URL to pop up? It's usually under Solution Explorer.
Sorry, you want the...
It's the properties window, but when I go to...
This?
I was talking about the one that's inside to the right.
Yeah.
That little window.
It's view and properties. Properties pages, the very last item in the view menu.
It's not property window. Property window.
Sorry.
Yeah, there we go.
Property window. Okay.
How did you get your local URL to the API?
Build it and copy it.
If you right-click the project
Oh,
Usually it shows here under application. That's odd. I'm not sure where the, here, under debug. That's the local. Okay, I think I got to delete my API from this morning because I think this is why it's failing, is I have a feeling I am out of disk space. So I'm just going to delete mine from this morning and try one more time. Okay, we'll go back. Try deploying again now. Once I get this to run, I'm going to try and hit the endpoints again from Postman, and then we'll try with the PHP file. While this runs, we can actually grab that PHP file. So if you go to lesson 11, there's a PHP file here that will call any API. You specify the URL of the API, you specify the method, get, put, post, or delete, and any parameters you want to pass into the method. So I'm just going to download this file. I'll just stick it right in here with my API project. Okay, yeah, I think that was the problem, was probably not enough disk space. So I think my API should be online now. Let's see. So there's no public page, but now I should be able to hit API albums. That's interesting because it told me it just deployed properly. That's great because mine from this morning was working, but now I've deleted it. Better go just check my Git repository, make sure it looks okay. Yes, I got git ignore. Try one more time. I may have to remove one more thing. Try this in Postman just while that's loading. Okay, Postman, it worked. Here's all my data coming from the API now. There, phew. So we can call get. I can get a single album, and then I could use Postman if I want to try doing post, put, or delete on here as well. Obviously, disk space was the problem for me. So now I want to try to call this from a PHP page. Rather than calling it from my local server Postman, I want to call it from a different application running on a different host altogether. So if you open up the PHP file you downloaded, it's pretty slick. Found this online. I probably should have made a reference to it. So it just uses curl. So there's a method call API where you put in the method name and then the URL. So down here, I'll just grab the URL to my albums. And I'll stick it in. And it's set up to make a GET request. So now I'm going to save this file. Now I could run it locally on my local web server, but I'm interested if I actually put it online on AWS or DreamHost, if it will successfully call my Azure API and fetch back the data. So I'm going to upload this to my AWS account. So you can throw this on any server, whatever server you use for hosting your PHP applications. Probably you have DreamHost, or you may have AWS. You may have both. So I'll go to my AWS account. So now if I go here, AWS, so now I'll run my call API PHP page. So it can go and fetch all the data. So this is just kind of a simulation for what you would do, what ideally you're going to do in Java instead. So once you publish an API, you're going to use Java to consume or make a call to it. So what Jarrett's going to show you is basically the Java equivalent of using curl in PHP. To take in it, pass in an endpoint and a method, and then parse the JSON that comes back out. Right, so we've kind of built two ends here, the client end in PHP, the server end in .NET Core. Now, in the event that you're not able to publish your part 2 for some reason, it doesn't run on Azure, so you can't consume it, well, you have a few options. And I've kind of explained these options to Jarrett. One is you could consume my API, or you could consume my Music Store API. I'll try my best to leave it online. So you could just consume the album data and show it in your Java application. Or there are many other JSON APIs out there that are available for public consumption. This one's pretty good. I suggested this one. Someone was nice enough to create a fake JSON API so that you can practice making calls and consuming the JSON data. So here are the different endpoints. Right? So you can see all of the different methods, the URLs. So you can try this free service. So you can always work with this API if you want. So I've shared this link with him. He may use one of these in class when you guys talk about this stuff in class. So let's look here. This brings me to one of the other things we should talk about. Normally, if you're going to create an API, you have a responsibility. Building the API and getting it online is one job, but there's another important job that comes along with it. Okay, two important jobs. We'll talk about security in a minute. Yeah, right? Because APIs are ways for other people's applications to talk to ours. So if you're going to build an API, you've got to write a spec for it. Because those other developers, they need to know what methods are there And for each method, what do I have to pass into the method and what can I expect to get out? If we didn't have that documentation, it would be impossible to work with this stuff. So these typically look like this, right? So here's this documentation. So we'll look at a couple examples of what this documentation looks like. Here, let's look at this one. If you're going to consume an API, so they're using the methods, well, they look familiar, right? Same as we're doing. We're not reinventing the wheel here. They give you the URLs. So here, we've kind of mimicked Spotify's API with our own. So with albums, that's what you can do. Right? There's the endpoint. Similar, gets all, gets one, and this is what it returns. And we can go in and read. So there's the endpoint. Here's the request. So this is what we need to take in. And here's the response. So we identify, typically we identify in a table all of the JSON nodes, the data type for each, and then we typically expect to see a sample. It's kind of like this when we did the Stripe API last week, right? It showed us all the objects. It showed us a sample of the request response and then a description. So we have to create this stuff if we're going to build an API. Otherwise, how is anybody else going to know what methods we have and what our methods will expect to come in and what our methods will return? Now, fortunately, there's a very cool tool. And there's plugins and packages for .NET called Swagger. Swagger generates with HTML, JavaScript, and CSS. As long as your API kind of follows the standards, Swagger will write the documentation for you, which is awesome. You can actually see what this looks like. So it's free to sign up. So this is integrated into Azure. So if we do a live demo, so they've got a little pet store demo API, right? So this is what the documentation that Swagger creates, right? They've color coded the method types, post, put, delete. So if we want to find a pet by ID with a get, it tells you in the request what it wants, shows you the status code of 200. And here, so this is an XML version. Here's the JSON version, right? So this is what it returns. So if we build the API, we can actually use Swagger to generate the documentation for us. There may even be something in Azure here, right above cores under API. Yeah, it lets us configure Swagger. So we create this API definition.json. We may even have this. So here's an API some students are building. I'm not sure where the docs are. I know they're here somewhere because I know he's using Swagger for this. So if we're going to create an API, you have to create those documents and you have to keep them up to date. If you're going to consume an API, well, then our responsibility is read the document and figure out how it works. I'll show you. So we've looked at a couple examples. I'll show you one that also ties into security. So that's the other thing. So our API is all public. Normally, well, it depends on what we're building, whether it's public or not. In many cases, we're requiring authentication, right? So we need some way of authenticating. If you think about how we authenticate, how do we authenticate when we did like Google and Microsoft login? But in order to call their API, what do we need?
You had to have a private public.
Right. We needed to create those keys in their portal, and then all our requests to their API, we had to include those keys. So that's a common way of doing it. Some kind of authentication token that gets included in every request. There's two common ways of doing it. One is that token just winds up somewhere in the URL. The other way we do it is we can attach it in the header. So that's what we've done here in this API. Let's see. So here's our API. Right, so we're using Swagger. This is .NET Core. And if we have a look at what's here, so here, for example, if we're going to go into one of these controllers, so what we're doing, notice in the constructor, we're using the .NET, ASP.NET identity package. So we have to pass in user objects in order to instantiate an instance of this controller. So it's rather than done on the method level, it's done at the controller level itself. So that way we can control access this way. So if we go to, say, users controller, we'll see the same thing. So we can use ASP.NET identity. The other way might look like this, where we pass it as part of the URL. I think I've got one here. So this was an API created by another developer. I think he built it in Ruby on Rails. The idea was we had users that were using both my web application and his. And what our clients, mutual clients, decided was they wanted everyone to log in through our application, but once they were in, they wanted them just to be able to click a button and automatically get authenticated in his application without having to log in again or without us having to share logins. So he built an API that allowed me to call all kinds of methods, but one of the things we had to do, it's not the right one. Let's see if I can find it. So he created this document that described the endpoints, request responses. He had a testing server. So what we had to do was generate an access token and store that in our database. And then we had to pass that access token in to every method as part of the header. So every time you had to pass in the ID and secret to the header. So if you were going to do a post to that URL, if you didn't have the token, you'd get an authentication. You'd get a 401 authentication error. So that's typically how we would manage access. So a few different ways. So here we've got the access token as a parameter of the URL. So it could go in the header or it could go directly in the URL, that token. So we didn't really have time to get into that, but those would be the few ways of doing it. There's probably a tutorial here if you wanted to see it. I'll just go here, quick look, and I will set you free. Let's go into APIs. Yeah, so they talk about how to use Swagger with .NET Core. There's actually a link for this. So how to set this up. So Swagger automatically generates your API documents, which is cool. Security. Well, this isn't particular to Web API. So I'm not sure if they've got a good maybe this one. So this is using identity server in, yeah, here, access control. So generating access tokens. So that is, it is buried a bit in here, but if you want to learn more about how to do it, it's here. You don't have to implement this for our assignment. If you do, I'd certainly consider it bonus. Yeah, I don't require it. So for part 2, create a new .NET Core application, connect it up to your database, and either build or scaffold your controllers, post it online so I can test your API with Postman. This probably shouldn't take longer than an hour or two. I mean, we did it in 3 hours, and I made lots of mistakes and was explaining all of it. Okay, so for Wednesday night, it's a reasonable goal. So then the next 2 weeks, we'll go back to our web application and we'll set it up to do unit testing in Visual Studio. All right. That's all for today, guys.